Alright everybody, what's up? I have some updates. Sorry it's taking me a little bit longer to get a video out. I've just had a whole bunch of things going on. I inherited 2 new orchids. These are some mini Phalaenopsis. I gotta repot them. They're in this weird foamy stuff. I'm moistening these now so later I can pluck this away from the roots and put them in proper medium and slightly larger pots because they're fairly pot bound. Otherwise they're looking pretty good. We've got a couple of things going on with our tissue culture operation. Why don't we take a quick look at some of our SIPs and other things. We have some Ophrys tentardinifera getting ready to be replated. Maybe next week I'll do that. Some more Ophrys mimosa have germinated. Ooh, looks like we got some contamination. Crud. Alright. I'll have to deal with that. Because I really want to save those protocorms that are in there. We've got slow but steady germination of speculum here. We've got our Acai that I've not started germinating yet. Reginae protocorm's doing quite well, getting big. It won't be long before they need to get replated, which will bring me to my next point of this video in just a few. Let's just see here. They're getting nice and round on that medium, doing quite well. Don't generally want to leave these open for too long. How are my other guys in here? Guttatum californicum coming along slowly but surely. We've got some carnivorous plants. One of the things I've been working on is making my own medium. I also planted some of those Phalaenopsis seeds from that seed pod last weekend. So I've got numerous plates of medium with seeds. Ophrys that are replated and in this cooler so that they can be at about 8 to 10 Celsius. They need to be that way for about 3 months in order to continue developing properly. They've got a light on them now because now you will induce the leaf differentiation and tuber development. I've been playing around with our agar and agarose in the lab. One of the things that I'm going to have to do when I replate the cypripediums and the other orchids is make medium that's slightly less firm for the roots to grow in properly. But our agar that we have here, as you can see, is from 1983. This thing is about, 13 years older than I am. And so typical agar has a gel strength of about 1,100 grams per square centimeter or something like that. This is about 2.5 times weaker, so you need about 2.5 times the amount of agar to produce the same strength. And so I've been making the different concentrations. See, that's pretty weak gel. This, I don't remember the exact concentration. I think that this was 10 grams per liter. 10 grams per liter of regular agar would be much stiffer than this. Meanwhile, for germination, we need this stiffness. This is 17 grams per liter. I did a compression test with water, which we know the weight of, to see at which point 5 and 10% solutions of our agar crumpled under the weight. And then we have agarose, which is even stiffer. So for agarose, you need even less of this material. Although for replating, it's still not as soft as the agar. So for replate, I may use the agar, and for seed germination, I may use the agarose. So I've been playing around with that. Yeah, see, this is 20% agar. Relatively stiff. 10% agar. which is 10 grams per liter. This is 20 grams per liter. 5% agarose, and then 2.5% agarose. That's not as stiff. And I took notes on all of this. There we go. So basically, the germination agar is almost 18%, whereas the germination agarose is 9%. For replating, you have 10% and 5.3%. The other thing I've been doing is making my own T839, because the T839 that's sold at Phytotech has casein in it, and they don't have a casein-free media, and I need a casein-free media. I can't order it custom because they have a minimum order and it would just be too expensive for me. So I've been scrounging up all the different materials to make my own T839. So you basically look at the ingredients list. You need things like magnesium sulfate, heptahydrate, and cupric sulfate, calcium nitrate, tetrahydrate, things like that. And so I've been getting my own ingredients, and I'm getting close to being done with that part. There are just 2 ingredients left that I need. Well, 3. And that's where we're going to come into the other room. So I need ammonium citrate and ferric ammonium citrate. So I've begun the process of actually manufacturing the 2. There are a series of complicated reactions. I right now have... Gotta turn the heat mat back on. Right now I have the 2 compounds in solution. They are submerged in ethanol right now. It's starting to precipitate out here, as you can see with the ammonium citrate. They're both mildly soluble in alcohol. I precipitated out the ammonium citrate last night, but I made a stupid mistake of going ahead and flooding it once again with ethanol, which dissolved it. Because even though it's not completely soluble in ethanol, if you have enough ethanol, it'll dissolve eventually. And so now I have to evaporate out all the ethanol. Same story for this. I made a batch of this stuff, but I actually burned it by overboiling it on the burner. So what I decided to do was flood them with ethanol, and I'm just using a vacuum to pull that ethanol out at a quicker rate than you would have normal evaporation. And just to give you guys an idea, it looks like there's a lot of ferric ammonium sulfate dissolved there, but actually last night I had a jar about twice the height of this in other jar that was full of the liquid, and it's reduced down about 2/3 of its initial volume. This guy is also much lower. It was all the way at the top earlier today, and now it's down 2/3 of the way. So hopefully within the next 24 hours it'll just be the crystals collected. What I ended up doing was making ammonia with a series of various chemicals and containers. You mix together solutions of ammonium chloride and NaOH, and you release ammonia. You catch the ammonia in water. You mix that with 2 moles ammonia to 1 part citric acid. I forgot the exact calculation. Ammonia is about half the weight of citric acid, so it's roughly 4 parts by weight ammonia to 1 part of citric acid by weight. And you mix those together, you get ammonium citrate. To get ferrous ammonium citrate, you first have to make ammonium hydroxide. We had NaOH, which is sodium hydroxide, and iron chloride. So you mix those together, you get iron hydroxide. You react that with a 65% by volume solution of citric acid, and then you add ammonia to that, and it goes from an orangey red to a yellow, and that's how you know you have ferric ammonium citrate. But you got to be careful not to heat the ferric ammonium citrate up too much when you're evaporating it off, otherwise you'll damage it. I learned that the hard way. So I just need L-glutamine now, and I'll be all set to replate the Reginae. So that's what's going on. I hope everybody enjoyed this update.